Good morning, students. Welcome to Sarva Siksha Abhiyan online classes. It is very happy to know the response of online classes from you. So keep going on like this and watch online classes very well and complete the worksheets which were sending to you by your teachers. Okay, students? Okay. So myself, B. Radha Devi, working as a physical science teacher at KGBV, Kallur. So today we are going to discuss about the lesson Is Matter Pure? So is matter around us pure? Which is from 9th class. Okay, students? Okay. So these are the keywords which will come to you from this class. So understand the keywords and write it to your notebooks. Okay, students. So first one is pure substance, mixture, heterogeneous mixture, homogeneous mixture, solution, suspension, colloidal dispersions, solvent, solute, concentration of solution, TYNDAL effect. These are the words which will come to you for this class. So, make a note in your notebook. Okay. Next. So, today we are going to discuss about the matter. So, what do you mean by matter? See, matter is nothing but which was present around us has a space and a mass. Has a space and a mass. Okay, students. So already these matter comes to you from your previous class. So now today we are going to discuss about that matter is pure or not. So in that we have a flow chart. See here matter has two types, pure substance, mixture. And pure substance mixture is divided into two types. See, in pure substance elements, compounds, and from mixture homogeneous mixture, heterogeneous mixture. See, by the examples I am giving you the idea of elements. Okay, so elements we got gold, copper, sulfur, like this. And for compound, water, baking soda, some vinegar, lime water. You can take any item which will combine with two or more elements. And for homogeneous, coffee, and for heterogeneous, pizza. Just look at this flow chart. I will understand you from the next slide. Okay, so homogeneous are, see, solution, and for heterogeneous we got suspension, colloid. Okay, and for examples are for suspension, it is a muddy water means mud mixed with water. Then for colloid, paints, milk, ice cream. And for solution, mixing salt with water. This is a schematic diagram or you can say flow chart of matter. Okay, these are the words we will discuss in this video. Okay, students? Okay. Then, now what is matter? Okay, what is matter? So, anything that occupy space and have mass is called matter. Okay, see, around us there is there are so many objects which occupies space and have a mass of it. See a person sitting in a room and around him see some butterfly, computer, coffee, desk, chair, everything which comes under matter. So everything which is a tiny particle means a small particle considered as a matter because it has some space in the universe, means in the earth, in the air, anywhere. Okay, and has a mass that considered to be as matter. So matter are three types, that is are in solid state, liquid state, in gaseous state. So we can define matter as a three states, that is solid state, liquid state and a gaseous state. Okay students, please look very carefully about these diagram or flow chart. Okay, then we will discuss about the pure substance which comes from matter. So what is pure substance? A pure substance is one which is made up of only one kind of particle. Means it is being made by only one particle. It doesn't mixing any one more particle to form a object or a substance. For example, platinum. Platinum, you see, like this you will appear platinum. So it is made by only platinum, like gold, you can take copper. So the thing or the object or the substance which is made by only one element, we can say that as a pure substance. Okay, so pure substance are of two types. What are they? One is element and second one is compound. Now let us discuss about these types. First one is element. See, what is element? An element is a substance which can't be split into two or more simpler substances. Means it can't be split into two more substances. It is made by only one element. It is made up of only one kind of particle. For example, iron. If you take an iron nail, iron rod, any knife, iron knife, anything, if you cut into small pieces, then if you look into these pieces into a microscope, you can observe that all these are made from one material, that is one element, ferrous, the chemical name of iron. Like this, gold, which is in solid state, is made by only one element, like mercury, which is in liquid state, and hydrogen, oxygen, which are in gaseous state. Okay, if you look into the carbon picture, see, coal. Coal is a substance which is made by carbon. Like that, diamond also. Diamond also is made by carbon. If you cut into the diamond into small pieces and make a powder, if you look into this powder with microscope, you can observe these element, that is carbon. So an element is a substance which made by only one particle. Okay students, it doesn't mix with another particle. That is nothing but element. Now compound. What is compound? A compound is a substance which is made up of two or more elements chemically combined in a fixed ratio by mass or a particular ratio. Means it is a combination of two or more elements. For example, we can take as water. Water is a combination of hydrogen and oxygen. Here there are two elements are there. Carbon dioxide, carbon and oxygen are there. Then salt. What is the chemical name of salt? NaCl. So it is a combination of sodium and chloride. So these are comes under compound because they are made by two or more elements. Okay. Now characteristics of compound. See, it is a pure substance. So water is a pure substance. Salt is a pure substance. Like that, compound which comes from two or more elements also, it form a pure substance. So they are represented by a formula. Now only I have said to you the chemical name of salt. Means NaCl, carbon dioxide, CO2, glucose, CH, H2O, O6. So this is the formula for glucose, that is C6H12O6. Like this, the compounds are represented by formulas. Then the third one is the properties of compound differ from those of its constituents. Constituents means elements. So the compound which is made by the elements, that element's properties only shows this compound. Okay, it doesn't show other properties which doesn't have the elements. Okay, then compound has fixed melting point and boiling point. They have a fixed melting and boiling points. Then constituent elements can be separated by chemical process only. So the elements which made by compound can be separated by chemical processes only. For example, if you want to separate hydrogen, oxygen from water, then you can use the method, electrolysis method. Means electricity process. Electrolysis, electricity. Lysis means breaking into pieces. By using electricity process, we can break the hydrogen and oxygen from water. Like this, we can use chemical processes to break the compound. Okay, students. See, here some pictures are there to you to understand. Water, which is made from hydrogen and oxygen. Ammonia, which is made from nitrogen and hydrogen. Sodium chloride, Na and Cl. These are the elements which forms a compound. Next, we will discuss about the next topic, mixture. So what is mixture? Let us see. A mixture is a substance which is consist of two or more elements or compounds not chemically combined together. So it is a type of substance or mixture which consists two or more elements are there, but they are not chemically mixed. See, if you look into this picture, here you have so many colors. This is called mixture. Okay, if you want to separate it, then it became an element. So the combination of two or more elements are nothing but mixture, and they are not chemically combined. For example, mixture of salt and water. See, by mixing salt into the water, it becomes salt water. So it is a mixture of two elements, that is two compounds. One is salt and one is water. Okay, so mixture are of two types. They are homogeneous mixture, heterogeneous mixture. Now let us discuss about homogeneous mixture. Okay, so what is homogeneous mixture? Those mixture in which the substance are completely mixed together and particles are distributed uniformly. Means in this mixture, which substances we are going to add, they are completely dissolved in the solution. Means they are mixed very well. They can't appear to us. For example, see, if you take a coffee, we make a coffee by using milk, water, tea powder or coffee powder, sugar. So after making a tea or coffee, we didn't have to observe the components which are mixed by us. Means if you want to see what milk, you can't see milk separately. So they are combinedly mixed together. Just like tomato sauce means tomato soup, lemonade means lemon water. Then chocolates, we make different types of components to make a chocolate. Then strawberry milkshake, we use different types of components to make these items, but after making these items we can't appear the components separately in these mixture. So these are called homogeneous mixture. We can't separate after making, and we can't appear the components after making. Okay students, the particles are distributed uniformly in the substances. Now we will talk about heterogeneous mixture. What is heterogeneous mixture? Those mixtures in which the substance remains separated and the particles are not distributed uniformly. In the homogeneous mixture, the particles are uniformly distributed. But in heterogeneous mixture, the particles are not distributed uniformly. Let us see one example. That is mixture of salt and water. If you add more salt into a little bit of water, you can't see the particles which are distributed uniformly. The salt will settle down at the bottom of the glass. So in these mixtures are not uniformly distributed. Okay students, see, if you observe the examples, mixture of chickpeas, you can add different types of chickpeas and that became a mixture, and we can separate, like this vegetable salad. This is also one type of mixture, but we can separate it. Okay. Then fruit salad. We can easily see how this salad makes by using different types of fruits. Okay, we can separate it. Like this, we can see so many mixtures around us which has heterogeneous. Okay. Now, let us discuss about the difference between homogeneous and heterogeneous mixtures. So, first one, all the components of the mixture are uniformly mixed. Means, in the homogeneous mixture, all the components are uniformly distributed, mixed. But in the case of heterogeneous mixture, components are not mixed uniformly, thoroughly. They can appear to our naked eye. So, no separation boundaries are visible in the homogeneous mixture. We can't separate the components which were mixed in the homogeneous mixture. But in the case of heterogeneous mixture, we can separate it. And we can appear. Okay, we can visible. We have the capacity to see what are the components we have used to make a heterogeneous mixture. Okay, students. Then it consists of a single phase. Means once you add all the components into this mixture, we have only single phase. Like that, if you take a lassi or a sugar water. So all are the components we are mixing into this. It make one item. But in the case of heterogeneous mixture, it consists of 2 or more phases. Because we can separate it. That's why we can make 2 or more phases. Okay. Then for example, sugar dissolved in water. Sugar dissolved in water. That becomes sugar water. Then in the heterogeneous mixture, examples, air. So air is a mixture of so many particles. Just like sand and a common salt. Okay, students. Okay. Then next is types of mixtures based on a particle size. Types of mixtures are there. Not only homogeneous and heterogeneous, some more types of mixtures are there based on their particle size. Let us discuss. They are solution, suspension, then colloidal solution. Now we are going to discuss about solution. What is solution? A solution is a homogeneous mixture of 2 or more substances. By adding 2 or more substances, it becomes a solution. A solution is a which type of mixture? Homogeneous mixture. Means completely we have dissolved the components which we are using to make a solution must and should be dissolved. See, solution has 2 parts or 2 components. What are they? First one is solute. Means substance which is going to be added in a less amount. Means lesser quantity. If you want to make a solution, we are using 2 or more components. The component which is using less quantity is nothing but solute. And the component which is using large quantity is nothing but solvent. For example, if you want to make a sugar water, here we are going to add sugar a little bit, means less amount. That is nothing but solute. And water is a solvent because here we are using water in a huge quantity, means one glass of water we are adding 1 tablespoon of sugar. Large quantity, less quantity. So here solution of sugar and water. In this solution, water is a solvent because it is very in large quantity, and sugar is solute because it is in less quantity to make a sugar solution. Okay, students? Okay. Then, so we have to discuss about the solubility. Means, what is solubility? Let us define. The amount of solute present in a saturated solution. Saturated solution is nothing but the solute which we are taking has to be dissolved completely, and that type of solution is called saturated solution. So the amount of solute present in a saturated solution at a certain temperature is called as solubility of that solute at that temperature. Okay, means it is a measurement of how much of solute we are taking to dissolve in a solvent at a certain temperature. Means at a certain temperature the solubility of components depends. Okay, so we have to know how much of solute has to be added to the solvent. See, if the amount of solute present is less, if you are adding less amount of solute, then the solution is said to be dilute. If the amount of solute present is more, then the solution is said to be concentrated. Means if I am going to mix 1 glass of water, 2 tablespoons of sugar to this glass of water, then it becomes sugar solution and it is very less. So it can tell as dilute. We can say it as dilute because it is a saturated solution. But if I am going to add more sugar, means 10 or 15 spoons of sugar to the water, then the increase of sweetness is happened, and in Telugu language you can't say it as panakam. So it becomes very sweetness. So we can say that it as a concentrated. Okay, if you observe the pictures here plain water glasses are there, 5 water glasses are there. Now if you add ink in an increasing order, means in the first glass 1 drop, in the second glass 2 drops, like that, third glass 3 drops, fourth glass 4 drops, fifth glass 5 to more drops, then what happened to the color? See, from light color to dark color, the color of the solution is increased here. See, if you look into the red ink, in the first glass the color of the solution is very light comparing to the fifth glass. If you look into the pictures also, the solutions of the colors are very different from first to last. So the solution which is in light color is called as dilute. If you are going to increase the color by adding ink or the substances, then it become concentration. Okay, now we have to discuss about the solubility by using this picture. See, solute, by adding to the water it become solution. So here three types of solutions are there: saturated, unsaturated, supersaturated. Saturated means little amount of salt has to be added to that solvent. Means particular amount is added to that solvent. If you increase the amount of salt or sugar to the solution, it becomes unsaturated. Means it takes time to dissolve it. If you are going to increase more solute to the solution, then it becomes supersaturated and it doesn't dissolve. It becomes unstable and settle at the bottom of the glass, like this picture. So solutions are three types, that is saturated solution, unsaturated solution, supersaturated solution. Okay students, so types of solutions. Aqueous solution means solution having water as solvent. Okay, then non-aqueous solution, solution having substance other than water as solvent. Means here water is not used as a solvent in these types of solutions. In aqueous solutions, water has been used. Then saturated solution, already we have discussed this one. It is a solution in which no further solute can be dissolved at a given temperature. Means no more solute has to be added to the solution if it have a little amount. Okay, then unsaturated solution, it is a solution in which more solute can be dissolved at a given temperature. And one more thing students, if you are going to increase the temperature, then the solubility also changes. Means if you increase the temperature, then the solubility will also increase, speedily dissolves. Means the solute particles will dissolve very fastly. Okay, then what concentration of a solution? So how can we define or know the concentration of a solution? So there are three types, that is mass by mass, means solid by solid percentage, mass by volume percentage, or volume by volume percentage of a solution. In this way we can calculate the concentration of a solutions. Let us discuss one by one. So define concentration means the concentration of a solution can be defined as the amount in grams of solute present in 100 grams of solution, and this is a mass by mass percentage of a solution. Means if you are taking two solid state of components, then how can we calculate the concentration of a solution? See, mass by the mass percentage of a solution can be calculated by using the formula mass of solute by mass of solution into 100. Into 100. Let us discuss with one problem. Suppose that a solution was prepared by dissolving 25 grams of sugar into 100 grams of water. Here we are making a solution by taking 25 grams of sugar and 100 grams of water. Now we have to calculate the concentration of this solution. So the percentage by mass would be calculated as follows. So how much amount of solute we are taking here? Solute means a little bit of component, that is 25 grams of sugar. Then how much of sugar we have, how much of solution we are making means we are by combining 25 grams of sugar and 100 grams of water means 125 grams. Okay, so by the formula mass of solute by mass of solvent solution into 100. By substituting the values here in this formula, we can define, see, mass of solute means 25 grams, solute 25 grams by mass of solution 125 grams into 100. 25 ones are 25 5s are, then 5 ones are 5 2s are, that is 20% of concentration is there for this solution. Like this we can calculate mass by mass percentage of a solution. Okay, then next is the concentration of a solution can be defined as the amount in grams mass of solute present in 100 ml solution. Here mass means solid, 100 ml solution means liquid. So how can we define mass by volume percentage of a solution? So it is here it is a formula is there. Mass of solute by volume of solution into 100. Okay. See here question is there. If a solution is prepared from 10 grams of salt in enough water to make a 150 ml solution, the mass volume concentration is, we have to find it. Okay, mass of solute, how much mass of solute he has given here? 10 grams. Volume of solution 150 ml. Then what is the formula we have? Mass of solute by volume of solution into 100. Okay, by substituting values we get the concentration of solution, that is mass of solute 10 by volume of solution 150 into 100. By cancellation we get 6.7% of concentration. Okay, then next is the concentration of a solution can be defined as the volume of solute present in 100 ml of solution. Here both are in liquid state. Let us see volume by volume percentage of a solution. By using the formula we can calculate, that is volume of solute by volume of solution into 100. Okay, let us discuss with one problem. A solution is made by making 40 ml of ethanol and adding enough water to make 240 ml of solution. The percent by volume is, see, Volume of solute is equal to 40 ml. Volume of solution is equal to 240 ml. Then by using the formula, we can calculate the value. Volume of solute 40, then volume of solution by 240 into 100. We got 16.7% of concentration of this type of solutions. Like this, we can calculate the concentration of solutions by using these formulas. Okay, students. Then we are going to discuss about the next types of mixtures, that are suspension and its properties. Let us see. A suspension is a heterogeneous mixture in which the small particles of solid are spread throughout a liquid without dissolving in it. Means a suspension is a heterogeneous mixture, means it doesn't mix very well, it doesn't dissolve, but it will spread on to the solution. Let us understand by an example also. Okay, I will give you example. The solute particles settle down when a suspension is left undisturbed. Means if you mix the solution for a long time and kept aside for a short time, then the solute which were mixed by us, they will settle down at some time. So they can be separated from the mixture by filtration. Some methods are there to separate that one. Okay. See example: muddy water, dust storms, chalk water mixture. For example, if you mix water and a chalk piece powder, the chalk piece particles are mixed very well into the water if you are stirring. If you stop stirring, then the particles will settle down, but they can't separate. We have to use separate methods to them to separate. Okay, for example, see, muddy water means mud water. Just like we can take it as a oil and water also. If you add oil to the water, then it looks like it may be separated, but they are mixed very well when we are stirred. Okay, these are the pictures to you to understand your concept. Lemon water, which is made from home, natural lemon water. Then next type is colloidal solutions. What are colloidal solutions? A colloidal solution is a mixture in which the substances are regularly suspended in a fluid. See, once again I am reading. A colloidal solution is a mixture in which the substances are regularly suspended in a fluid. Means they will suspend at the bottom of the jar in the form of fluid. See, let us see the examples. Classified into different, by seeing the examples we have to discuss types also. Let us discuss. They are dispersed phase, means the solute, like a component of the dispersed particles in the colloid form, the dispersed phase will appear. Means if the dispersed phase is nothing but the solute particle. Okay, and the dispersion medium is the component in which the dispersed phase is suspended, is known as the dispersing medium, means solvent, which are going to settle down at the bottom. So two types of colloidal solutions are there, that is dispersed phase, dispersed medium. Dispersed phase is nothing but solute particles. Dispersing medium is nothing but solvent particles. Okay. See examples for colloidal solution. For example, foam. A foam means nothing but if you add surf to the water, by stirring we get foam on top of the water. So a colloidal solution with a dispersed phase gas and a dispersing medium solid or liquid is called foam. Means we appear the bubbles from the top of the water in the form of a gas. But here we have used solid means surf and the water to make a foam. This is the one type of colloidal solution, and we can take it as example shaving cream also. By rubbing it very well, it gives a foam. Okay, like this examples here also some more there. See examples of colloids in real life. Body creams, bread, yogurt, beer, toothpaste, ice cream, milk, and here also some examples are there. Detergents, cosmetics, paints, blood, gel. These are all comes under examples for colloidal solutions. Next, aerosol. Aerosol means a colloidal solution with a dispersed phase means solid or liquid and a dispersing medium gas is called aerosol. Means they are first dispersed phase is here solid and liquid. After dispersing medium it is a gas form. Let us see the examples. Example, clouds. Means if you talk about the clouds will form by vaporizing the water. Means water is in liquid form and it became a solid. In the liquid form it converting into gas form. Okay, and it is appearing like a cloud. Then in the pharmaceutical aerosols, means in the pharmaceutical fields also we got some examples for aerosol. See some type of sprays are there, inhalers are there, some sprays which will give gas state. We are using body perfumes, everything are in a gas state only. Okay, like that. Next is sol. What is sol? A colloid solution with a dispersed phase solid and a dispersing medium liquid is called sol. Means it will comes from solid, means dispersed phase is solid and the dispersing medium is liquid. Let us see the examples. Gels. First it is in a solid state, then it will comes from liquid. Just like here some pictures are there. See, gel is formed by mixing some with powder and a water, it form a gel. Then solid in liquid sol means paint. Then ruby, garnets, these are all comes under sol, which has a solid phase and it will appear dispersing medium in a liquid. Okay, then emulsions. What is emulsion? A colloidal solution with a dispersed phase, liquid, and a dispersing medium, liquid. Both the states are here. Liquid is called as emulsions. For example, cold creams, milk. These are all comes under emulsions. See, mayonnaise means to mayonnaise is used to make a cakes or one type of chocolates, all are okay. Then butter, milk, salad dressing, everything comes under emulsions. Moisturizing, here in the syrups also we got some type of word, that is emulsion. If you look into the picture very keenly, you can get that emulsion term. Okay, then here cream liqueur, soft drinks, fruit drinks, coffee creamers, these are all called as emulsions, means which are in a liquid to liquid form only. Okay, then classification of colloids. See here, dispersed phase is there, dispersed medium, name of colloidal system, common examples. Dispersed, in the first one, dispersed phase is liquid, dispersed medium is gas, means first phase liquid gas if you get, then it is a liquid aerosol. Example, mist, clouds, fog. If the dispersed phase is solid, dispersed medium is gas, then become aerosol, dust, smoke. Then gas, liquid, it become foam, that is suds, wiped creams, and so on. Like this way we can classify the clouds into different types. Okay students, you can make a note to you in your notebook. Then the last topic is TYNDAL effect. See, the scene is very nice, no? And this type of appearance is nothing but TYNDAL effect. What is that? TYNDAL effect. See, if you look into this picture, here a light source, means a torchlight light has been focused into the three types of solutions. One is normal solution, one is colloid, and another is suspension. See, if you focus onto the solution, not the light rays are not visible in the solution, means it is a water. And in the second one, it is little bit visible, it is a milk. Milk is a mixture of milk and water. Okay, then if you come to the last one, it appearing very nice. Why? Because the particles are settled down at the bottom of the jar. That's why it becomes very clear. The particles are striking the light. Okay, this is nothing but TYNDAL effect. So what is TYNDAL effect? TYNDAL effect is the scattering of light by particles in a colloid or else particles in a very fine suspension. So TYNDAL effect can be observed in the colloidal solutions or a suspension solutions. Okay, so it is a type of scattering of light. See, if you, for example, it can be observed when sunlight passes through the canopy of a dense forest. Canopy is nothing but it is a cover of, it is a full spread of forest. Okay, see, in the forest the sunlight scattered the leaves, the branches of the tree, and it will give sunlight into the darkened place, If you look into this houses also, into our houses also, the light rays are coming from the window. It is also nothing but Tyndall effect. Okay, students. So Tyndall effect is nothing but scattering of light in a darkened place. So, and this is the worksheet to you for this session. Make a note of these questions, and if you have any doubts, you can watch the video once again and you can clear your doubts. Okay, so must and do these worksheets for your better understanding of concept. Okay, students. Okay, these are the 12 questions to you for this session. Thank you.